Okay, so I just want to show you how to write out the balanced equation for esterification. So our first example then, ethanoic acid, 2-methyl-propan-1-ol. So the way I do it is I will draw it out so that I'm displaying the functional group. That's a good practice. So there's my ethanoic acid, 2-methyl-propan-1-ol. So the alcohol, notice I'm drawing that in line with the OH on the carboxylic acid, and you'll see why in a minute. So propan-1-ol, so carbon 1, 2 and 3, and then that methyl group on carbon number 2. Now obviously we wouldn't leave it like that, we need to get those hydrogens on, so just finishing that off like that. Okay, so if it's displayed that they ask for, then you'd have to display all those hydrogens as well. Okay, and the reason why I've drawn it like that is because for the condensation reaction you're bringing these two molecules together, so it's that one plus that one, and to remind yourself which bonds to break, I say leave an O on both. So if I leave an O on each one, I'm going to leave that oxygen on there, so I'm going to break this bond here. I'm going to leave an oxygen on here, so I'm going to break that bond there. So you'll see then that this carbon is going to effectively join up with that oxygen, and we've got the small molecule being released, and here it's water. Now it's a reversible reaction when it's done with the conc sulfuric acid with heating under reflux. So if we draw out the products then, so CH3, and then there's your C double bond O, okay, and now that carbon is going to attach to the oxygen there, and look, there's your ester functional group, okay, and then we've got the CH and the rest of that molecule there unchanged. Okay, so there's your ester. Now of course if this is a balanced equation, at the moment it's not balanced, and that's a common error for people to forget about this H2O. So do make sure that you finish that off there, plus H2O, you've got your two products there. Okay, so I'm just going to rub the top off here, because you saw how time consuming it was to draw all those hydrogens. Okay, so it's always a good idea to practice doing skeletal formula as well. So remember, it's like a dot to dot, so that carbon, if I start here, okay, that's the first carbon, that carbon there, and then I need to do the double bond O and then the oxygen. Okay, see how much quicker that is. The oxygen then attached to a carbon here, so we've got 1, 2, 3, so 1, 2, 3, and then don't forget we've got this CH3 on carbon number 2 effectively there, so there's 1, 2, so there's that CH3 there. Okay, so do have a practice at doing skeletal formula as well as displayed. All right, hope that's helped. For the rest of the PowerPoint, you're just going to see the computer drawn molecules, but I just wanted to do that first one with your hand drawn so that you can see a good technique how to show them reacting. Okie dokie, thanks.